Hello everyone and welcome to another video of Mastercam. So we have already studied in module number 5, which is all about the multi-axis toolpaths, and we have covered the topic of introduction to multi-axis and 3+1, which is also known as 4, and 3+2 5-axis rotary positioning toolpath. We have also covered the swath and swath milling and the most interesting toolpath, which is the automatic roughing 3+2. It uses the 3-axis and plus 2-axis, make it 5-axis roughing toolpath. So today we are going to start the multi-axis pocketing in an advanced application. So let's get started. So I have already opened the software which is known as Mastercam Design, and what we are going to do is we are going to create a design. I'm going to select a front plane for creating a design and go to view and select the front plane. So let's get to simple wireframe to create your 2D profile. What I'm going to do is I'm going to select a line command, select this on a horizontal, make it length of 100 millimeter. Okay, click again, make it upward direction, make it 50 millimeter. Click again, make it 100. And again make it 5 millimeter and back here 100. So what I'm going to do is I'm just going to create a revolve profile, and this will be my profile, and it will be revolve around this profile, this line. Okay, so let me show you. Go to solids, select your solid profile, your solid revolve command. And what I'm going to do is I'm going to select this revolve command, revolve profile, and where it's going to be rotate around this axis. Okay, so just create a 3D profile. So now what I'm going to do is we are going to study the pocket operation of multi-axis pocket. So let's create some pocket around this cylinder. Okay, so what I'm going to do is going to make it wireframe again, go to view front, and let me make some pockets using a simple rectangle command. Click here, make it 75, and the height is make it 40. Okay, give some round fillets around it. Adds a fillet. So just create a simple, I'm using the simple tools to create. I'm not using any complex tools. So we create a rectangular profile on the front plane. Let's make it on the top plane. Okay. So I just select the construction plane to top, select rectangle, select the center. So let's make it 75. And the other profile is 40. Okay, it around edges. That's it. Okay. Now what I'm going to do is I'm going to extrude this. So go to solid, extrude, select your chain. It's now top. Okay. And it just create a cut body. Let me show you. So it create a cut body here. Now go to front plane, and what I'm going to do is I'm going to select this chain and cut here. Cut here. Okay. So we have two profiles, or we can say two features, cut features on the cylinder. And what we're going to do is we're going to create a pocket, multi-axis pocketing for these two features. Okay. So for let me hide all these in wireframe. Go to home, select blank, just hide. So first thing first, the main thing you need to add in this solid model is we need to create a floor for this pocket. So in pocket feature, you have a floor and you have a thickness, cut thickness here. We can also say that we have a wall thickness here. So actually we have wall thickness here, but we don't have any floor. It's an open pocket. So for multi-axis pocketing, you need a floor and the wall. We have wall, we don't have any floor geometry. So what we're going to do is we're going to create a floor for this pocket with two pockets, okay? So for that purpose, go to wireframe and select these edges using the curve one edge command, okay? So I selected it and hold on the shift key to select all the single chain curve command, okay? Let me hold and click on this edge. It will automatically select the chain, okay? So now do this same with this edge. Okay. So we have two 3D curves, not 2D curves. We have 3D two curves here on this cylinder face. And what we're going to do is I'm going to close these curves using the surface command. And in the surface command, we have a lot of tools here. And for these curves, we can use the power surface, which is an AI tool. Okay, so select the power surface, select the chain. I'm going to select this chain. Okay, click one more. So it creates surface. Okay. So it creates two surface and close down these two pockets on the cylinder face. Okay. Now our model is completed for the multi-axis pocketing. Let's go to machine. Select your milling machine default, and now it's time to select some stock material. Go to stock setup and go to block, boundary box, and select the cylinder. We have a cylinder here, okay? So we don't have any radius and height. So what I'm going to do is I'm going to select the cylinder face. Let me select by manually. Click. So the radius is 50 and the height is 100 mm. Okay, that's okay, right. So click OK. Now we have all the definitions. So now let's go to multi-axis and select the pocket. So here we have the pocketing command feature. Let's go. The tool type which we are going to use is pocketing, and the tool. So let's select the tool. So I'm going to use a flat end mill, which is a 5 mm end. Okay, and set the spindle speed to 20,000 RPM and branch rate is 1000. Okay, and make it 3000, and the retract speed is 2000. Okay, and give the tool number is 1. And the holder. Let's talk about. The holder is default. Okay, go to stock. So we have already stocked this setup for this model, so we don't want to change anything because we have set up the stock. Okay, or if you want to create stock, you can go to stock model and select create a stock model. Okay, you can get it from here. So the most important or crucial step is the cutting pattern or cut pattern. You have to define the cutting region, cutting geometry, and the floor geometry and the wall geometry for this pocket. So let's define the machining geometries, which will be the wall in this case. Okay, and now select the floor geometry. Let's select the floor. Okay, if you want to leave some stock, just give the value. It will definitely remove that material or leave that material. In case you want to leave that, remove that material, you just need to enter in negative, write negative symbol here to get negative, or remove that material, not need, but move that material. So next, move towards the pattern. We are going to perform the roughing operation. Yes, we are going to perform roughing. We have a solid stock. We want to create a pocket here. So select the roughing. If you want to do the floor finishing, you can select floor. If you want to finish the wall, you can select the wall finishing. But we are going to perform the roughing operation. Okay. And the strategy is offset from the floor. So we have 3 options here: offset from the floor, offset from the ceiling, and offset morph between the ceiling and the floor. But most importantly, we use the offset from the floor according to our geometry, any geometry. So this floor is going to be offset according to the wall and according to the cylinder shape. Okay, So now let's go to the type. So definitely we use two options here. We have the offset and the dynamic. So we can use both of the tool according to your design, but mostly we use the offset type. Okay. So the tool will be offset according to the geometry. Okay. In dynamic, it just follows the dynamics of the geometry. But in offset, it just offset according to tool path, according to tool, and then finally follow the geometry. The sorting method, next thing is the sorting method, which is one way, zigzag or spiral. You can select the zigzag because it takes less time to cut the material, increase the efficiency. You can say that it takes to cut from both sides, from the forward and the backward direction. Okay. So how talk about the direction of the machining way? It's grind milling or the convention. Mostly we use the grind milling operation. In this direction, the cutter's direction, and the workpiece direction is in the same, and give some more finish to the object, which is going to be machined. For the roughing operation, we use the conventional machining operation, and it depends upon the type of material you are performing, and the material tool and the workpiece material and the operation which you are using. So let me make this default climate. Let's go to area tab, and in area region you have two options: the rest rough if you want to remove the rest of the material, or you want to assign a containment, or we can say that the boundary. So let's define the boundary conditions here. So we have a boundary here, and we want our machining to be done within this region. Click OK. And the next area is the depth step. You have to define the depth of cut each because you think that this is the wall thickness is the 5 millimeter, and 1 millimeter mean that it will take 5 cuts to remove that material. Okay. So the constant depth of step is 1 millimeter, and the step over is 2.5. I'm going to use the 50% of the tool. We use the 5 millimeter tool. Let's show you 5 millimeter and mill, and the step over should be 2.5, which is 50% of that tool. Okay. Or you can set the slice number. For example, the thickness is 5 millimeter. 5 slices mean you can take 5 steps to cut that material, mean to say 1 millimeter each time. Okay. We use that 10 slices. Definitely it means that it will take 10 steps to remove that material. Okay. So let's select that constant depth of step. And now the next thing is the first depth of cut. As you know that we set the 1 millimeter, but first cut should be, you have to define the first cut if you want. So mostly when cutter is going to be plunged in this workpiece, it should take a minimum amount of 0.1 millimeter cut. And the final step of depth of step cut, we can say that the finishing operation, let me say that it could take 0.01 millimeter depth of cut at the last for final. Okay. Let's go to tool access control. Don't have any option here or any settings. Tool collision, we have checked the against machining. Let's make it default, and then linking parameters. So linking parameters, we have to define the first entry is the rapid distance. So it will definitely follows the rapid distance, rapid area, and the last should be the rapid. So let's make this feed distance and last exit to the feed distance. And now the default links. So as you see that there is no links between the cutting tools, so it should be direct. Mean to say it should be go to the feed distance and then take the cut. So let's define that the links between each tool path or each region should be blend line. So let's see. Let's show. Let me show this. So it does link with the other. Okay. In the direct there is drag, but in blend option it just follows these. And then in between groups, let's define blend supply. Okay, so it just follows it. So this is how the linking option is done. We have the feed control, roughing operation, that's make it automatic. That's okay. So let's click OK to create. So it's processing. Let me show you. So this is how the multi-axis toolpath is created here. And you see, let me show you in wireframe. So you see that it takes 5 steps to complete that. 1, 2, 3, 4, and 5. So each step contains 1 millimeter depth of cut. Okay. And you see that it stacks blend spline with the other toolpaths. So it will definitely decrease your machining time and increase your machining efficiency. Okay. So this is how we can create the multi-axis toolpaths. Let me go to backplot setting and go to setting. Let's select the simulate row 3 axis. Okay. And let's make it slow. So as you see, the cutter is getting down and it will just follow the path. Okay. So this is how the cutter will work. You see that the cutter is in a tilt position. So definitely uses multi-axis. Okay. Let me show you by go to machine and select the machine. Go to select 9 axis centroid, simulate it. So this is the 5 axis machine, and let me slow down. Let's machine and turn mode is NC. Click OK. So this is how the multi-axis toolpath works. So it's simultaneously using the X, Y axis and Z axis and the C axis and the A axis. Okay. This rotation, the C axis, or if we have the X axis in this direction and it's rotating, and if you can say that it's all about A axis rotation. Okay. So this is how multi-axis toolpath or multi-axis pocketing work. So let's define the other pockets. Let's close this. So you can either transform your toolpath to this point, or you can also let me show you that you can transform this toolpath. Let's go to transform and go to toolpaths and transform the toolpath. So we have to rotate the toolpaths, and what we are going to do is we have a source of NC code and rotate about from 0 degree to 90 degree, or 0 degree to just define that if you want to make it on the right angle of to make tool at 90 degree, click OK. So it just make it at this type. So it's a top plane. So let's go to transform plane and go to rotate. Select the rotation plane. It's not a top plane, but it's a right plane according to this. Okay, this plane. Click OK, and here you see that it's just transform the plane. Transform the toolpath. You just don't need to create any toolpath. Or either if you want to create more, you can go to toolpath, create more, and it will just create more toolpaths. Okay. So this is how we can create multi-axis toolpath using the Mastercam, and we have learned how we can transform these toolpaths in this. Okay. So let's go to machine and run the simulation. So let me select toolpath all and run. So let's click OK. So this is how it looks like. Okay. That's on the other side. This on the other side. Okay. So the red means that it's getting collide with these. To collide, there is a collision between the workpiece and the tool. This is because of the, you see that this line, this color line represent that the tool is being transferred to other position and collide with this workpiece. So for that purpose, you need to create a link between that. So you see here this link. So this link definitely touches down the workpiece and cause the collision. Okay. So let's go to parameter, and what I'm going to do is make it 2. Okay. And go to home and unblank. Let me unhide this. Okay. So select the construction plane right. I'm going to select wireframe. Let's make let me make this here a line. What I'm going to do is I'm going to define this point on this area. Okay. So it will move, retract from this point and then go to this point and then here. Okay. So let's go to Toolpaths, go to 2D, and here we have a manual point, manual entry and manual point. So let's define the rapid here at this point. Okay. And okay. So this point is here. Let me move up here between the roughing and the transfer tool part. Okay. So here, let's do this. So it doesn't change anything. So it just go there and then here, go there and then again here. So let's delete this. Let me go and create a copy of this roughing tool part. Copy and paste and go to parameters. First thing, I just need to unhide and go to cut pattern, just clear this. Select this surface, floor surface, and the container. Okay. So we don't need any other things to be changed. It's okay. So what you see over here, that we have created a point on this point. So the cutter will perform all the operation, then go back to its retract position, then back to this point and here point. Okay. So this is how we can create a point for the cutting tool to be entered. We can say that the entry of the tool is this point. Okay. So let me hide this. Also this. So let's simulate it. And at this point, you will see, and let's make it slow. And you see this, it will never cross the workpiece. And here we go. So this is how multi-axis toolpath actually works. So hopefully you understand how we can create. First we create the simple geometry using the wireframe. Then we revolve around the axis. We create a 3D model. Then what we do, we just create surface to close down the pockets, and when create the and then we apply the toolpath. After doing the toolpath, we just transform the toolpath using the transform toolpath method using on the toolpaths, and we got an error. So for moving that error, we just create a point of reference where the tool will go back and then move to other toolpath location. Okay. So this is how we can create multi-axis toolpath. Hopefully you enjoyed that video and stay tuned for more videos. Thank you very much.